evil, necessarily. But when I say 6 through 35, every other pair, that's explained at the top. The reason I do that is because there's little groupings of homework, right? And they have like 4 problems in them. The first 2 are a certain way, the next 2 are a certain way. Instead of assigning all of the damn things, I want to assign the middle 2 so that you get a taste of each type. The easiest way to do that was to make you guys do a pair, skip the next pair. Do 6, 7, don't do 8, 9. Do 10, 11, don't do 12, 13. Do 14, 15, don't do 16, 17. That's what every other pair means. And again, I don't do that to be mean. I just do that so I can give you all the different types of homework without making the whole thing do. Right? Now, if you didn't really adhere to this, just go back and do maybe some of the even ones you skipped. Right? But yeah, there's a purpose behind this. And again, it's not just being evil, it's just the quickest way to assign everything. So I don't know if you had to do, which one was it, 22? And I don't really care, we can still do it. 22. 22 says this. N is 2,000. X is 400, and they want a 95% confidence interval. And finally, this is full blown out. They want the whole confidence interval. Personally, I kind of don't like the problems that break it up, but I just give it to you just so you can see all the pieces. But here's a full blown problem. So I've got to use this whole thing here. And again, the book says phi hat plus or minus e. I just put the whole damn thing together. Might as well. So what do I need to be able to plug in here? Do I have z yet?
No.
For a 95% confidence, what's z?
1.96.
And that makes sense because way back with empirical rule, within about 2 standard deviations was 95% of the data. So if I want to catch 95%, it must be about 2 that I go out. And it's actually 1.96. It's one of the ones that keep showing up over and over. So this is a z-score of 1.96. Cool. What about p hat? How do I get p hat? I love it. 400 divided by 2,000. Which is who what? Point 2. What's q hat? I love it. So now we got q hat, we got p hat, we got z, we got n. We got everything we need. So part of me hates this because a lot of people teach it by just purely what I just did. Here's a formula. I'm not going to tell you why. Find what you need and plug it in. And I hate that. But it's easy. On one level, that's all it is. Get the right formula, plug this stuff in the right place, put it in your calculator correctly, and you're fine. Nothing major to it. But I want you to understand why the hell it makes sense. I know it's probably not what I saw. It's give or take something. It's somewhere in there. That should make sense. It should be close to this. So now I just plug and chug. 0.2, give or take. 1.96 steps. All right, so my suggestion would be to calculate the error first, and then you add it to 0.2 and subtract it from 0.2. So see what error we get. Cool. 0.018. I love it. And I just have to 0.2 minus this and 0.2 plus that, right? It's pretty nice. There is no plus or minus key. I have had somebody in the past ask me where the plus or minus key was on the calculator. That would be kind of funny. That'd be kind of cool. But it doesn't have it, sorry. You got to do it separately. 0.2 minus 0.018 is 182. 0.2 plus 0.18, 0.218. So how would you write the statement that you know I'm going to make you write on a test? We are Yep. 95% confident. Which means we think there's only a 5% chance that we're wrong. That's really what we're saying there. We're 95% confident that the interval 18.2% to 21.8% does what? We're 95% confident that that interval, so like throwing the fish net out. What do I want to do? I want to catch a certain fish. I'm 95% confident that this interval, this fish net, catches the true, or contains, if you want to, contains the true percentage. What was this all about? Did this have a meaning? Not yet, Jeff. Oh well. It contains a true percentage of the population. That is the idea. And that's why I make you write that statement, because one thing is being able to do the numbers. That's great. The bigger thing about statistics is to interpret what the hell you did. That's actually the slightly more important part. How's that?
So, what's the formula that you use for problems like that? What do you call that formula? That's the
Confidence interval for population percentage or proportion. Yeah. That's the full-blown title of that.
Can I ask you about the 0.18?
Oh, just 0.2 plus 0.018,
Oh.
right?
Oh.
And 0.2 minus 0.018. Just one at a time, yeah. Cool. All right. Any other questions? Good, because we got we got a lot to do. All right, so a little review. We basically reviewed 7.2 right there. The other formula that we looked at. So we've got this formula here. P hat. So we got that from 7.2. The one that goes right along with that. So what we saw, give or take, how much we think we're off by. Right? Both of those formulas are the same. They just have their situation stuff in there, right? Here I'm talking about percentages, here I'm talking about sample means. So they both have kind of the same format. So we actually got this formula from this formula, right? I don't know if you guys remember that, but we did. Okay. There are also, if you want to find the sample size required to be within something, and this would be your error, right? If I want to say I want to be within 5 pounds of somebody's weight, that's how much my error is, right? At most 5 pounds, give or take 5 pounds, right? So if I want to find how large of a sample I've got to take, let's say I got to be within 2% of the true percentage of people that smoke. So I want to, okay, how large of a sample do I have to take? For 7.2, it would be this formula. And for 7.3, it's this formula here. Cool. And really, both situations are just solving this. E equals this, solve it for n. That's really what both of those are. Take the error for this one, solve for n. Take the error for this one, solve for n. A lot of things are squared because n is being square rooted. So at some point I got to square to kill it, right? Okay, cool. Yes?
So these formulas that you just put down are to find what?
These two find what? These two find
probability for percentage.
all right, good. With very little prompting, I love it. Except that I gave you the answer, that's right. These two do this. All right, you see what they found? They find the sample size. That's what n represents, right? Before I go out and take a sample to find something, to get a feel for something, maybe somebody's going to tell me, okay, Johnson, I need you to be within 0.03 millimeters of the true average length of these sprockets, right? Like, oh shit, okay. And before you go out and take a sample, you're going to say, well, can I do some work to see how large of a freaking sample I've got to take to do what he wants? If my sample only has to be 38 big, and I didn't do this work, and I went out and talked to 600 people and measured 600 freaking sprockets, I didn't have to do all that work. You see what I'm saying? Or if it comes out to be that the sample size needed is 8 billion, well, screw that. I'm going to go back and say, boss, you would need 8 billion sprockets. You don't pay me enough for that kind of shit. Maybe you want to go down a little bit in how close you want to be. You guys see what I'm saying? That's why these are important formulas to know. So that you can see how big of a sample do I need to take to be within so much. How close do you want to be? Okay. Let's do one example of one of these sample size problems, I think. Because I gave you guys the answer key for this one here, right?
No. Or you showed us the way you do it.
Oh, I'm evil. I'm evil. Oh, did we do this? We did this together in class?
You did the whole one. You didn't do the middle one.
Which one did we not do?
C.
Oh, cool. Well, now, okay, perfect. Do C. Let me put it up here. Oh, that's right. This is not the one I gave you guys. Oh no, but I actually gave you a little different version, I think, if I remember correctly. On the one that I gave you guys, is there a number 3 or does it go up to 2? 2, okay. So I didn't give you the new version. 2. So we sample 652 voters and 459, that's the registered voters. 459 voted. Find a 99% confidence level. Okay, cool. Now, just to get you guys started, which formula do you need for part C? 1, 2, 3, or 4? For part C. So it's got to be one of these two, right? You can eliminate. I'm not asking for a confidence interval, so it's neither one of these. It's got to be one of these, and I'm talking about true mean on part C. So it's got to be this guy. Yeah.
Where did you find the Z?
Z, that's the reason why I wanted to do the updated version, because I didn't say which one, but it's from part A, 95%. So at 95% confidence. Here. Bless you. What's your error in part C? No, what's your error in part C? 0.5. I want to be within 0.5. You have control over the error. You want it to be within 0.5 inches, and you're seeing if you can do it. How big of a sample will I need? And again, if it turns out to be 8 billion people, there aren't 8 billion people, so that's kind of impossible.